Another type of the manometer that we have is the differential manometer. So it means that we can just measure the difference in pressure between upstream and downstream in a pipeline. And it's the YouTube. So like a YouTube like this one, but it's not like the is if we're just gonna like the upside down the YouTube, so we're just gonna have like an inverted YouTube. Okay, so we have an inverted YouTube differential manometer, and we have once we have like the pipe liquid or the liquids in both limbs, at the top of that we have the air. We have the air confined between these two kind of like the liquids, and we have a valve here to just adjust or bleed the air. Okay, so that's like the situations that we have in here. So the way that we're just going to calculate this one is more or less the same as that one. The only difference is that with the like the normal YouTube differential manometer is that once you're just going to draw a horizontal line, in this case you can draw through the upper surface of separation, not the lower surface. The upper surface is the only difference between inverted YouTube with the normal YouTube differential manometer. So once you're just going to draw the horizontal line, because we have like a two separation surface of separation, one in here, one in here, we just draw a line through the upper surface of separation. Once we're just going to draw that one, we just in the second step, we're just going to write the equation for the pressure for each limb or for each of the 2 points of in the pipe, for example, by starting from the bottom of each limb, for example here, and equating the pressure in the pipe to the sum of the pressures caused by the weight. For example, in the left hand side there's only one type of the liquid, on the right hand side we have this kind of liquid, and also here. But just bear in mind, we're just going to just write everything for the liquids. In here we have like the air, so the air here and air here, so we're just going to discuss about that. So we only need to just write the total sum of the pressure caused by the weights of the liquid. If you have like a stratified liquid, we're just going to write all together, but the air we can ignore it. We can discuss and see in this example. And third step, we can subtract one of the equations from the other one, or equating on the right hand side and solve the equation or algebraic equation for differential pressure. So let's look at this in this more specifically. So in this figure, if we just going to draw xx line, we for the left limb we can write the P1. Okay, the P1 pressure at this point is equal to we have just by the way we have like the once we're just going to draw this one on the left limb, we have the on the right limb we have the Z2 is the depth of the liquid. On the left hand side we have the total depth of this one, but because of like a differential difference between like the left and right is equal to h, and we assume that Z1 is the difference between the point P1 and the lower surface of separation. Okay, so we just gonna write the Z1 and H1. So once you're just gonna write the P1 is equal, if you have like a two, you can just write the total depth, or in this case, we can just write like the rho G Z1 plus rho G H. If you have the total figure, we can write all together. And at this point, plus Px. Okay, so the P1 is equal to the pressure all in here plus Px. So just bear in mind the first and the second term on the right hand side. In the right hand side has got the same density. Okay, so we can just write the total depth together. Anyway, for the right hand side, we can just write P2 is equal to rho GZ2. Okay, plus let's just write this one, and if the density of the air is rho A GH, so we're just going to write it together up to this point, which is equal to Px. Okay, plus Px or Px, sorry. in this case, we can easily ignore the density of the air because the density of the air is really, really small, like the 1.2 kilograms per cubic meter. And imagine this amount of density and compare that one with the density of the oil and water, which is like 800 at least, and 1,000. So it's like 800 or 500, 600, 700 times like the smaller. So you can easily ignore, and it's not like a bad estimation. So you can easily remove the second term, and for the right limb we can just write P2 is equal to rho gz2 plus Px. So if we can just subtract the equation 1 from the equation 2, because the left hand side are not the same, so we can subtract and differentiate the left hand side. P1 minus P2 is equal to right hand side rho gz1 rho gh Px minus, inside the bracket, there are two terms, rho gz2 plus Px. And if we cancel out or simplify the inside the bracket, rho gz2 can be written, can be kept here, but the Px can be canceled out from here, inside and outside the bracket. So we're just going to have that one. As a result, we have three terms, rho gz1, rho gh minus rho gz2 on the right hand side. And if we factor rho g, we can write inside the bracket h plus z1 minus z2 as the result here. Okay, so with that introduction, let's just go and write what we're just going to do. And imagine in this figure, we have difference in elevation between 0.1 and 0.2, which is equal to A1. Can you see the difference between P1 and P2 is equal to A? A can be written here because Z1 and Z2 here can be written here as a Z2 minus Z1. Or you can just write like the minus A is equal to Z1 minus Z2. And if you substitute minus A with the term Z minus Z2 inside the bracket here, we can easily write P1 minus P2 is equal to rho g h minus A. But doesn't matter, just like the parametric. If someone is happy to just use this one, you can use this one. But normally for assessment, you are supposed to just write the whole procedure together. And in this case, you can easily write P1 minus P2. If it's like a horizontal, for example, just in case that there is no like the horizontal and we don't have like any A is 0, P1 minus P2 is equal to rho gh. Okay, so as a like the summary, P1 is equal to rho gz1 plus rho gh plus Px. P2 is rho gz2. If we have like the, for example, other like the liquids than air, for example, if you have like the oil, and here you can write like the rho 0 gh plus Px. So in this case, the upper like the liquid is not air, or we have the air here. Sorry, we have like the oil here. So once you have the oil here, you can just write, you cannot like remove this one. So if we just gonna take the difference, rho A is replaced with the rho oil in here. And once we subtract here, we have like a longer term. Only the Px terms are canceled out. And apart from that, 4 terms are left. If you factor the rho g, we have 3 like the parameters inside the bracket minus rho oil, rho OGH. So this is like the situation, and we can just go with the like the difference of the level of the 2 points, the same as the previous slide, as minus A. You can write substitute with the Z1 minus Z2 in this equation. So as you can see here, in this term, that term of the rho of the density of the upper, like the liquid or gauge liquid, is left in the equations. So in here, even if the pipe is horizontal, A is 0, the difference in pressure is equal to GH rho minus rho oil, or rho like the pipe, density of the pipe liquids, minus the density of the gauge liquids. With that introduction, let's go and see an example. We have a manometer used to measure the pressure, measure the difference in pressure between the 2 points in the pipe. The pipe carries water with a density of 1,000. above the water in the manometer is air. Okay, it's not like the oil, which is a pressurized. Manometer readings is like the Z1 is 100 millimeters, Z2 in this figure is 250 millimeters, and H is 90 millimeters. What is the value of P1 minus P2 in newtons per square meter, or the difference in pressure? Just bear in mind, all the figures is like in millimeters. Once you're just gonna do the calculation, you need to just convert all of them in meters. So we're just gonna go together. The first step, draw an x line in upper surface of separation. We're just gonna write. Second stage, we're just gonna write the pressure for P1 is rho gz1 plus px. Okay, so you can ignore this distance. And for the right limb, we can just write P2 rho gz2 plus rho gh plus px. If you subtract equation 2 from equation 1, we can just write this equation. If you can cancel out and simplify, P1 minus P2 is equal to rho g. Inside the bracket, Z1 minus Z2 minus H. And if you substitute like the rho is 1,000, G is like the 9.81. Inside the bracket, we have 0.1 is like the Z1 is 100 millimeters, it's like 0.1 meters, minus Z2 is 0.25, minus, which is a Z2, and H is 0.09. Okay, that's the H. And the difference in pressure is equal to minus 2.35 thousandths newtons per square meter. So just bear in mind and pay attention to this point that the difference in pressure is minus. So meaning that we have like the minus pressure here, and the pressure at this point is lower than the pressure at this point. So the pressure at this point is like higher than that.